Hello. Let's see how the 7th challenge from 2019 Flare-On competition could be solved. The challenge is called wopr. Let's start by checking what we actually get in the challenge. We get two files, the standard message and some application, which that's quite big, but let's start with the message. So the message says we used to own our own computer hacking skills to find this AI on a military supercomputer. It does strongly resemble the classic 1983 movie War Games. Perhaps life imitates art. If you can find the launch code for us, we will let you pass to the next challenge. We promise not to start the thermonuclear war. Okay, that's the challenge description. And what I did actually in this challenge, I start by running in VM. So I have my VM here. So if we start this application, it actually prints some loading, prints some ASCII art and greetings Professor Falcon. And it, I guess, awaits our input. And actually, if you open this exe in some decompiler or disassembler, you will not get anything useful. Well, there is some code, but it doesn't look like it's actually responsible for printing the actual code. So what I did instead, I ran process hacker, and let's just show details for all the process. And what we can already see is actually there are two instances of this application. So I guess this one that we run, and it actually spawns the other one. That's quite interesting. And if we open this one and if we look at modules, there's not that nothing that interesting, I guess. There's standard stuff. But if we do the same on the second one, it actually, we can see there are some like PAD, Python core, and Python 3.7 DLL. So we can assume that this actually, it's a Python application compiled to exe or some kind of Python application that is being run from the main exe file. So that's something. What I did next, actually, I tried to look through memory. And I don't know if that was on purpose, but actually I got really lucky with this because I got the full source code of the application. So what we can see on the screen, we have this greetings Professor Falcon. So let me try to look for the greetings in the memory of this other application. So not the one that we executed, but the one that was executed from within the first. So greetings is 2, 4, 6, 8, 9 characters. So let's just use the strings. We just put the limits at 9. So basically we'll at least potentially get greetings. We'll get all the strings, and now we'll just filter to contains greetings. And what we can see, we have this greetings Professor Falcon, greetings, greetings, greetings Professor, but here we have something that looks kind of Python. It looks like greetings and like a Python array, and the length is quite big. So let's just go there. And if we scroll here, there are some strings, a lot of them, but yeah. But if we scroll down, actually we get the Python code for all the application. So I don't know if that was kind of one of the ways to solve this challenge, to get the source code. But yeah, we can get the source code of the whole application this way. And this is how I did it. So when we already have the source code, we can actually look into this source code and see what's actually happens there. Of course, I can't drag and drop. So let me just open source code. So this is what we get. So this is the whole source code. For now, let's just skip this wrong method. There is some terminal class that actually deals with printing characters on screen. That also doesn't interest us for now. And yeah, we get to some interesting stuff here. We get some XOR array with some values. we see the aforementioned wrong method that being put into the list, and then it's being sorted with those values. And then we can see some code that actually deals with input from the user. So we can type like help games, list games, help, blah, blah, blah. And we can see some other like really cool world map being printed. So what actually we need to do here, because like if we scroll down, we can see, okay, congratulations, you found the flag and the flag is printed, and the flag is being decoded with some input like this from this array and the launch code. And the launch code is actually what we input, and it's being just converted to the list. And here we can see some kind of XOR operation that being performed on our input, and it's like third, fourth, fifth, ninth, 12th and 15 character being XORed together and put in B0 and so on for the other values. And then this B array has to be equal to H, the H that we saw before. So actually here we saw this H. So whatever is in H, it has to equal what we input, that being processed by those XOR operation. And I think it's just XORs. There's nothing else but bunch of XORs. So it's not, doesn't look like that complex, but there's like, the input is used in multiple places. So we need to be sure that we get something that is correct. Okay, but we skip this wrong method for now. So let's get back to it at this moment. So this wrong method, what does it do? It actually, from the first look at it, it's might be quite complex, because the names that it's being used are like some kind of obfuscated. It's used like issue, digital, truth, expertise, so nothing really connected with what it's actually doing. But if we try to analyze it, it actually reads the memory of the application. Actually, it's opened the application, the one that's being run, so it opened itself and goes through some data in the text segment or in other segments and extracts some bytes from it. So it's basically all of that could be summarized that it opened itself, get to some segments, get some bytes from those segments, pack them into ints, and then at the very end it generates MD5 of those bytes, and that's it's being returned. So actually this H value will be some bytes read from the memory of the process, converted to MD5, so the hash of those bytes will be calculated, and this is what actually our input will have to match. Of course, this is XORed byte by byte by this XOR value, but it doesn't really matter because this is just byte by byte, so it doesn't change that much. So we have two things that we need to find out in this challenge. First, what actually this returns, because we need to have this value and also XORed with those bytes in order to generate some input that it will match this value. So we have, that's the first unknown. We don't know what this actually returns. And the other unknown is actually how to convert this that we will know into what values in X that after they are being XORed with those equations that we see here, we'll get the correct values. So we have two unknowns, as I mentioned, and let's try to solve them one by one. So the first unknown, what does this wrong method returns? So how I approach this? I actually, approach that I just copied the method and try to use it directly. So yeah, I couldn't execute it from within the application. So what I did, I actually modified a little bit. So this is more or less the wrong method, but in order to get the data, I use this read process memory function that I found somewhere that takes the PID and it will open this process with this PID and will read some memory of this process. I'm using this C types from Python to actually get some data from the process. That's one thing. And then the other one is that I need the base address because there are some calculation done in this wrong method. And I just need a base address to get some data correctly. So it wasn't really, it was some kind of manual approach because I need to put those data whenever I execute the script. So it actually changes from start to start, but nonetheless, it's the best I could think of for the moment, just to have something that works. So let's try to see if we can actually get the data correctly. So we have our process running. So if we look at the process hacker, we have the PID, it's 3892, and then we need the base address of this process. So we can also get that. Maybe I didn't have to close it actually. So we have base address EF and 4 zeros. Let's try to see if it will work, if I didn't make any mistake. Okay, and then let's just open another console here. Okay, let's just go to Flare and 07 and then Python, and we have solution 2. Okay, and we get some data. So this is actually, there are some printing done and we get the bytes. So it's basically what we did. We opened the process of this application running here. We execute the wrong method with some a bit modification done with this base address because yeah, we didn't have the same base address of the code. So we needed to adjust for that. And we get the data, we hash them with MD5 algorithm, and then I already like XOR it. So this is after the XOR already the operation being done. So yeah, we got something, but that's just the first thing that we needed to actually solve this challenge. And the other one is solving this equation with the XORs. And I have it done outside this VM, so let me just switch to here. And here I have another script. So I get 2 scripts, and actually here I'm using Z3 to solve those XORs. So I created like 15 or actually 16 bit vect variables, named them, gave them 8 bits, okay, and I just put them in an array to have easier access to them by index. I have my solver, I have the bytes that actually was from running the previous script, and then I just implemented those XORs with those constraints in to the solver. So I added them one by one. Yeah, so this is just writing the same as we can see here to the solver. Then we check if it's solvable. We extract the model. Here I'm just getting the values as a long and converting them to characters and just printing them to the screen. Okay, and already I have it here, but let's just run again. So it's satisfied and we get the value. So it's like 5C0 something, but let's just check if it actually will work. So where's our... Okay, so let's just greet. Okay, hello. We don't know what we can do. Let's help. We can list games. Okay, there's tic-tac-toe. Oh, global thermonuclear war sounds interesting. So let's play global Okay, let's play the game. Please specify primary target. Okay, let's just be not to upset anyone except Martians. Let's call Mars. Okay, and then we need the launch code. Let's try and see it would work. And it didn't work. So it didn't work because, of course, I had to modify my script before the recording. So never do that. Because in the beginning, my print was kind of lame. It printed just the initial values. So I thought, well, I will fix it. And yeah, I want to be cool and just print the actual ASCII. So you notice that I have X15 as the last item. But of course, we start from 0. So what mistake I did? It should not be 15 here. It should be 16 here. So yeah, never modify your scripts before actually you start recording, because I was actually missing one character. Too bad, but let's continue. Let's see if it will work now. So we just need to start our global thermonuclear war again. So play global war. Okay, let's again try to hit Mars. Yay, accepted. Okay, now the simulation being executed. Okay, it looks like no one is winning. I don't know if it's good or bad. Maybe it's good. Let's see how many more simulations. Okay, a strange game. Yes, it is. And we found the flag. So the flag is linear algebra is fun at Flare.com. I guess it's it's mentions of those equations, I guess. They are, I guess, linear. But yeah, so this was the 7th challenge. Quite fun. I was a bit stuck at the beginning when I didn't see any useful code in Ghidra, or when getting the binary there. But yeah, got the whole source code. That was actually very useful, and from there it was just a few simple tricks that need to be done to get the flag. So yeah, fun challenge. I hope you like it. If something is not clear, let me know and I will try to provide more info how it was solved. But if you do like it, yeah, hit the like button, subscribe, and see you next time on 8th challenge from Flare on 2019. Bye.